All right, welcome. 12.4 is the last lesson of the year. Let's begin. Okay, the Great Pyramid, right? Great Pyramid of Giza right here is a square pyramid. It's got a square base and is shown below. Has the following measurements. The following, what is the ratio of the slant height to half the side length? Okay, so let's do that ratio real quick and see what happens. So if I take the ratio of the slant and divide it by half the side length, just curious what we end up with here. So 756 divided by 2 is 378. I wonder what that ratio is. I just take those two and do that. Let's see. So if I do 612 divided by 378, whoa, 1.619. If you remember, 1.618 was that magical number that shows up everywhere. And it just happens to be in the pyramids as well. Interesting. All right, next, what is the volume of the pyramid? That was the only weird thing. What is the volume of the pyramid? Volume of a pyramid is 1/3 base area times height. So the area of the base would be 756 squared, because you do 756 times 756, it's a square base. So it would be the area of the base. And then the height of this pyramid. So we're going to have to actually make a right triangle. Imagine this is going down. Okay, so you have that situation. So let's take that triangle out and look at it. It would look something like this. This would be 756 as well. So this length would be half of 756 at 378. Okay. And then the hypotenuse is 612. And then we could quickly do a little Pythagorean theorem to figure out the height of that. We could do h squared plus 378 squared equals 612 squared. Ran out of room. And then we'll just plug that in the calculator. 612 squared minus 378 squared. And then, so h squared is equal to that. Now you got to do the square root. Don't forget. Hopefully you've done this enough by now, or this is second nature here. So 4, we'll call it 481. Give it one decimal place for accuracy. That is the height. Okay. Now I'll just plug that all into my calculator. Since I already have this number in my calculator, okay, even if you don't have a nice calculator like mine, it will store the answer. So you can do 1/3 times 756 squared times the answer, and that'll give us the best possible solution to this. So pretty large. That's a big number. 916,95466. So 91, about 91 million cubic feet. Think about that. That's how many little cubes, foot by foot by foot, make up the Great Pyramid, which is pretty crazy. Now, suppose the Egyptians chose to build great cylinders instead of great pyramids, such that the height of the cylinder was the same as the diameter of the cylinder. So instead of making pyramids, they would make great cylinders. How cool would that be? All right, where this length is the same as this length. All right. So that's what they're saying. What would the dimensions be if they used the same number of little cubes? What would the dimensions be of the cylinder? All right, so let's imagine what that would be like. So the volume of a cylinder is pi r squared h. The volume would be this. It's be the same volume, just different shape. So 916954466. Now the radius would be half the height, or if you think, call that radius, and then call this 2 times the radius. That's the relationship. The diameter is the same as the height. So that's what I'm going to use in my calculation. I'm going to use radius squared and then times 2r, like that. All right. So one thing I can do here is, sorry, hold on, making tea. All right, there we go. I can divide the pi over. So let's go ahead and get rid of that pi. So I got this number already in there, so I'm just going to divide by pi. Gives me that. And then, so I got rid of that. I'm going to get rid of the 2. I'm going to divide by 2 now. Gives me that. So I have 1, 4, 5, 9, 3, 7, 8, 6 equals r cubed, like that. So that's r squared times r would be r cubed. Now, how do you get rid of an r cubed? You have to raise to the 1/3 power, or do the cube root. But anyway, these will cancel now. And you have to do it to the same thing over on this side. So raise to the 1/3 power, like that. I'm left with about 244. We'll call it 244. So the dimensions of the great cylinder would be 2 times 244. So that would be 488 feet tall by 488 feet wide. Imagine a cylinder that tall. What's that? How would we reference that? Let's see here. How tall is 488 feet? How tall is the Sears Tower? Let's see. Let's look that up. Okay, Sears Tower is quite a bit taller than that. 488 feet. I don't know, it's hard to imagine. Okay, now, next. Although not all of the blocks are the same size, Egyptologists use 2.5 tons and the following dimensions as the weight and dimensions of an average pyramid stone block. Okay, assuming that the pyramid is mostly solid, how many blocks did it take to make the pyramid? All right, well, one block is 3 by 3 by 6. So what is 3 times 3 times 6? So it would be 9 times 6, 54. One block is 54 cubic feet. Okay, the pyramids weren't made with little cube foots. In fact, the measurement foot wasn't even around back then. But they're saying in general, these blocks were pretty big. In fact, these blocks were roughly 54 cubic feet. So now take the volume that we found above, 9169546. And divide it by 54 to see how many blocks it took. So that 9169546 divided by 54, that's how many blocks they had to set in place. All right. Now, how much does the pyramid weigh then? If each block weighs 2.5 tons, all right, how much does the pyramid weigh? So now take that number and multiply it by 2.5. So times 2.5. We can say the pyramid roughly weighs this many tons, which is pretty large. And each ton weighs 2,000 pounds. So now multiply that by 2,000. You get a very large number. This is how much the pyramid weighs. It weighs this many pounds. That is 8 billion pounds. 8 billion pounds. That's crazy. Can you imagine the man labor that it would have taken to raise 8 billion pounds? Not only raise 8 billion pounds, but then you have to quarry 8 billion pounds and then move it from the quarry to the pyramid site. Now, if it takes 10 minutes to set each block in place, how long would it take to build the entire pyramid? 10 minutes per block. And there's this many blocks. So 10 minutes per block, that would just add a 0 onto that. So 1698064 That's how many minutes it would take. Now let's think about that in terms of something that actually makes sense. Minutes doesn't make sense to us, but 1698064. Okay, that's how many minutes. There are 60 minutes in an hour. There are 24 hours in a day. There are 365 days in a year. Actually, 360.25 days in a year, technically. So it'd take about 32 years. About 32 years to complete the pyramids. Holy cow. And that's just putting them in place. That's not mining them and stuff. So just think about that. It takes 32 years. That is just insane. Okay. Next, let's talk about it's called unit pricing. Now, typically you buy things by the volume, right? You buy like a certain volume of Coke. So it's a certain volume of Coke per dollar. All right. So which of these is the best deal? Okay, you could buy the 2 liter, which is the standard kind of large Coke bottle. You can get a 2 liter soft drink for buy 2 for $4. You can get 222 milliliter can of soft drink on sale for $2.99 per 6-pack, or this 2 for $10. All right. So what are we getting? What I want to know is volume per dollar. I want to know how much volume am I getting for every dollar that I'm spending. So in this scenario, we have 2 liter soft drinks for 2 for $4. So if I buy two liters, that's 4 liters altogether, and 1 liter is 1,000 milliliters. So 4 liters would be 4,000 milliliters. So in this deal, I'm getting 4,000 milliliters for $4. All right, that's an easy ratio, right? Just divide by 4. You're getting 1,000 milliliters for $1. Okay, so we would write that as, here's the deal. For this deal, it is 1,000 milliliters per dollar. You write it like that, 1,000 milliliters per dollar. All right, what's the next deal? 6 packs of 222 milliliter cans of soft drinks on sale for $2.99 per pack. All right, so 6 packs. 6 packs. Okay. So $2.99 per 6 pack. All right, so a 6 pack has 6 cans, and each can is 222 milliliters. All right, so how many total? 222 times 6. That's 1,332 milliliters. And we're getting that for a price of $2.99 per 6 pack. So that is, we get 1,332 milliliters for $2.99. Okay, now divide that by $2.99, so you get $1 here. I always put the dollar sign on the wrong side. So we're gonna do divided by 2.99. Oh, interesting. So this deal, even though it's on sale, you're getting 445.5 milliliters per dollar. So what's the better deal so far? This one, you're getting almost more than double the amount of Coke in this deal. All right, now last deal here. Let's see, 12 packs of 355 milliliters. Okay, so you're getting 2 for $10. So 12 packs. Oh, by the way, these are the mini cans, right? So 12 times 355, and you're getting 2. You're getting 2 12 packs. So I'm going to multiply that by 2. So that's 12 times 355 times 2. You're getting 8,520 milliliters for $10. How much is that per dollar? So divide that by 10. You're getting 852 milliliters. So 852 milliliters per dollar. All right, so what's the better deal? This one. You're getting quite a bit more volume per dollar than the other two. And the mini Coke cans were the least price, the worst deal. Probably because you're spending so much more money on the cans, right? There's more packaging involved. All right, next, number 3. A king needs to know if his crown is made of gold or a different metal. In order to find this out, you have to know the volume of the crown. How can you find the volume of the crown without destroying the crown? Well, spoiler alert, there's a picture. But how would you know that? How would you know how to find the volume of a crown? Well, go on Canvas and watch this video. Unfortunately, I'm not here to show you the video, but There it is. And it's very interesting. It's the word eureka comes from that. There's a guy named Aristotle back in the Greek times, and he was commissioned to do this by the king. The king wanted to know if the goldsmith made his crown out of pure gold. And so in order to do that, you have to know the volume of the crown. But how can you find the volume of the crown? Because the crown is not a perfect cylinder or a prism or a sphere or a cone. It's a weird shape. So how do you find the volume of a weird shape? And he ended up taking a bath, and as he got into the bath, he noticed that as he got into the bath, the water level rised. And he realized that the displacement of the water, how much the water went up, the change in volume of the water was equal to the volume of his body. And so he figured out a way to find the volume of shapes that are irregular in shape by just placing them in water and then looking at how much the volume changed. All right, so here's an example. Suppose a crown is lowered into a cylinder with a radius of 8. So this is a radius of 8 that is filled to a height of 4 inches. So originally this was 4. When the crown is lowered into the cylinder, the water raises 6 inches. Sorry, it raises to 2 inches. So this was 4. And now this is now 2. See how it raised up? It raised 2 inches. What is the volume of the crown? Well, the volume of the crown will be equal to the change in the volume. It's equal to this. This is equal to the crown. All right. Now the volume of a cylinder is pi r squared h. And then we can just figure that out. That's 2 times 64, so 128 pi. And to finish that off there, about 402 square inches. So pretty big crown, apparently, right? But there you go. Now we know how to find the volume of anything. We found the volume of prisms, cylinders, pyramids, cones, spheres, hemispheres. And now we can find the volume of any shape by looking at the displacement of the water. Okay. So here's another example. Mary wants to find the volume of an irregular shape. She puts some water into a rectangular prism. The water raises up 2 centimeters. What is the volume of the rock? Well, the volume of the rock will be equal to this. All right, that's the volume of the rock. 2 centimeters high, 15 deep, and 10 wide. So the volume of the rock is just 10 times 15 times 2, which is 30 times 10, 300. 300 cube. Did I put cubes, cubic feet? All right, I think since I'm not here, I think 6 is as far as we're gonna go. Might make 7 a bonus or something. We'll see. Last problem, and it's a good one. Gotta go out with a bang, right? Okay. Find the volume of the pizza with a depth of 8 units and a radius of Z units. So here's our pizza. It's a Chicago pizza, right? Deep dish, right? Got some volume to it. Here's our pizza. And it says the depth is A and the radius is Z. So we'll just do the volume of a cylinder again. Pi r squared H. The radius is Z. So that is Z squared. And the height is A. All right. Now let's just write this all out. We have pi. We have Z squared times A. Ha! Look at that. That's fun. That's a good one to go out on. All right. Number 7. We need to pour a concrete slab. Can you come up with a quote for my concrete slab? Also, I need to buy a new furnace. Can you come up with a quote for my furnace based off of my square footage of my house? So there you go. All right, we're going to make that a bonus. And